students, it's Mr. Sargent here with your Day 72 recap video for ELA and for Science. Now, all throughout our lessons today, we focused on one thing, and that is soccer. Now, soccer is a game that I've never played, but I love watching on TV, and I think the science behind it is just incredible. So we started this morning with your morning warm-up, which was a story about how things move. All right, we have a few questions. We're going to go back and find our answers, of course. And then I had you guys get in your reading groups and read three different books, and then report on them. In science today, we're going to be focusing on the physics of soccer. All right, we have a quick readworks.org activity, and we're going to see some video of a lesson that I taught a few months ago dealing with the physics and science behind soccer. So sit back and let's go ahead and get started. The first activity that we did was our Thursday warm-up activity. Now, this is a reading comprehension that you can find on your Google Classroom or in the link below. It's called How Things Move. Now, this is going to be a science reading comprehension story. Now, the big thing about this activity is all of the answers that you're going to write down, we can find in the story. So, ladies and gentlemen, let's go ahead and start reading it. We can watch things around us move. When something is in motion, it changes its position. Objects can move from one place to another. They can move in many directions. If you roll a ball, it might move in a straight line. It might also move in a curve. A swing can move back and forth. A light switch can move up and down. Fans have blades that move in a circle. If you want to know if something is moving, you can compare it to other things around it that are not moving. If the things behind the objects are changing, the object is probably moving. If they are not changing, the object is probably not moving. You can measure the distance an object moves. Just measure the distance between where it was when it started to move and where it was when it stopped. Distance can be measured in inches, feet, yards, or miles. Those measurements are in the customary system. It can also be measured in millimeters, centimeters, meters, and kilometers. Those measurements are in the metric system. All right, so now we have our 4 or 5 questions. Question number 1, when something is in motion, what does it change? Well, do you know? Well, let's go back in the story and look for key words in our paragraph. Now, when I look at the question, I look at the word change and I look at the word motion. Those are both key words. And if you notice in paragraph 1, they are both bold words, aren't they? So it brings our attention right to those. And if we read the sentence, when something is in motion, it changes its position. So our answer for number 1 is position. Fairly easy, isn't it? And then we'd go back and we'd underline where we find our proof in our story. All right, question number 2, how does a swing move? What's a key word in that question that would help us find it in the story? Very good, swing. So let's go back into the story. And once again, if you look, paragraph 1, there's the word swing. And right after it says a swing can move back and forth. So for our answer, we'll put back and forth. We'll also underline it in the paragraph as well. Number 3, how does a light switch move? Well, if we're following the pattern of underlining or finding key words in the question, probably light switch isn't mentioned many times in the story. So let's go back into the story and find the word light switch. Well, there it is right there. It says a light switch can move up and down. So our answer for that will be, for number 3, up and down. And we're also going to make sure that we highlight it or underline it in the story. So go ahead and do question number 4 and 5 on your own. And like I said, I would love to see the highlighting and I'd love to see your answers. Now, for the rest of class, we did something fun today. We got into our reading groups and we read 3 different stories about soccer. Now, they all looked at it looked at soccer in a different perspective or a different way to look at it. The first story we read was The Soccer Game. This was about Herbie and learning how to practice. All right. The second story we learned was Jayla Cole, Queen of the Goal. This is a story about finding your own place on a team. And then we have our last story, The Great Shape Up. Now, The Great Shape Up is about, well, eating healthy and getting in shape while using soccer. So I encourage you to check out your Epic website and your Epic books and read at least one of these books. Create a BME, create a bubble map, but pretty much what I want you to be looking for is what are the lessons that we learn in each one of these stories. In Science Today, we learned a little bit more about force and motion and the science behind soccer. The first thing that we did was we took a look at the Study Jam site that had a video on force and motion. All right. Then we took a look back at an older video that I had made of how we use force and motion, friction, and all of the terms we've been talking about this week in soccer. So let's go ahead and watch this now.
Okay, Sam, let's practice that kick of yours. Show me what you got.
Here goes nothing.
Okay. If you're gonna reach the goal, you're gonna need a lot more force than that.
It's not force I need, Mia. It's skills. I'm just not so great at soccer.
Sam, skills aren't gonna do you any good if the ball doesn't move. And if you want motion, you need force. Watch.
Now that's what I call a kick.
Thanks. What it really is force. A force is any push or pull on an object.
And your kick was quite the push.
Definitely. Before, the ball was just sitting there, waiting to be moved. The force of my kick sent the ball into motion. The crazy thing is, if my kick was the only force pushing on the ball, then it would just keep on moving. It would never stop.
That's impossible.
No, it's not. It's inertia, the tendency of an object to resist change in its motion. Inertia is what kept the ball still before I kicked it, and keeps it moving once a force is applied. Once something starts moving, inertia will just keep it going.
But what if that was like a bowling ball you just kicked? Bet inertia couldn't move it so far.
Well, a bowling ball would have barely even moved with the tiny amount of energy you kicked with. It's got a lot more mass than a soccer ball, and objects with more mass respond more slowly to force because their mass actually increases their inertia.
So that means it's harder to move things with a lot of mass and harder to stop them, right?
Exactly. But once you get those masses moving, inertia takes right over and keeps things rolling, just like the soccer ball. Well, unless...
Unless I stink as bad at kicking bowling balls as I do soccer balls?
No, unless another force is applied to it, like gravity pulling it down, or friction. Friction is a force that acts against moving objects.
Is that what made my ball stop?
Well, that's part of it, yeah. Friction acts between surfaces that touch. The friction that stopped the ball was caused by the bumpy, rough texture of the grass. The force of friction fought against the force of the kick.
And it looks like friction won against your kick, too.
Looks like you're right. That ball's done rolling for now.
Definitely. So then how do we beat the force of friction and get the ball to keep moving?
Well, the more friction there is...
Oh, the more force you need to apply?
Exactly. Or more newtons.
Fig newtons.
No, Sam. A newton is a measure of force. Anyway, you were right. Greater force equals a greater change in movement. And the more force you want, the more energy you'll need.
Of course.
Aha. Now you say of course, but when you kicked that ball earlier, I didn't see you put much energy into it.
Well, I had no idea I was fighting a battle against friction. Now I know just what it takes.
Not so fast. Sometimes, friction's not the only thing you're fighting against. Gravity is another force that can work against motion.
Whew. Friction, mass, gravity. No wonder this soccer business is so hard. That's like a whole team against one rolling ball.
Well, you just gotta come to the field in full force, Sam. Ready to give it one more shot?
Well, if you're talking about the basics of force, I think I've got that down. A force is a push, like a kick, or a pull that acts on an object. We need force to set objects into motion, and the greater an object's mass, the more force that's required to move it. Force not only moves things, it stops them too. friction is a force that acts against motion and can stop an object in its tracks.
But not this time. Go for the goal, Sam.
Oops. Guess I'm quite the force to be reckoned with now.
So if you just noticed that it talked a lot about some of the words that we have been talking about all week. It talked about friction, it talked about force. And though it didn't quite come out and say it, it mentioned all three laws of motion. Now, a few months ago, I did a video on the three laws of motion and your assignment today, which you can find on your Google Classroom and also in readworks.org, on the science and physics of soccer. All right. Now, in the video that I made, which I'm going to post a little bit about it and post the actual video in the link below, I mentioned how all three laws of motion are present in the game of soccer. We have Law 1, Law 2, and Law 3. So let's go ahead and see just what I did and see me as a younger me. This was filmed back in April. So let's go ahead and take a look at it now. Behind soccer. Now, if you notice from the story, there were a couple of words that were mentioned. I remember hearing force, gravity, and motion. So in this next part of the lesson, let's talk about Newton's three laws of motion and let's see how we can make them work with, well, a soccer ball. So the first thing we're going to take a look at is Newton's first law of motion. An object at rest will stay at rest until acted on by another force. How can we show that with the soccer ball? Well, let's try to figure it out. Here we have a soccer ball, and as you can see, it is not moving. So according to Law 1, this ball will not move unless there's a force acting on it. Right now, the only force that's acting on it is gravity, and gravity is pulling it down to the ground. So let's see what happens when we add a force behind it. So as we were able to just see, when I added the force from my foot to the ball, it was able to move. An object at rest will stay at rest unless acted on by another object. Law 1. Next, we have Law 2. Force is equal to the mass of the object multiplied by its acceleration. Okay, there's a lot of higher order thinking words there. There's a lot of higher order science words there. So let's keep it simple. What Law 2 says is the heavier something is, the harder it is to move it. Now, this soccer ball is not that heavy, but the more force I put into it, the further and faster it's going to go. Now, the ball didn't go very far, did it? Did I put enough force into it? Is that going to help me be a better soccer player? Or do I need to add more force? I think I need to add more force. That was way, way better. I added more force to it. And if you notice, it went straighter, it went further, it went faster, and there was enough force behind it to hit the wall and bounce right back. That leads us to law number 3. Law number 3 is for every action, there's an opposite but equal reaction. How did the last video of me kicking the ball show an opposite but equal reaction? Well, I kicked it, it went that way. It hit a wall, and then it bounced right back to where I kicked it from. Opposite but equal reaction. Now, if you don't know what a reaction is something that happens after you do something. All right? We've noticed from some of the other science videos that when you add different chemicals together, they react. In this case, with our laws of motion, whenever there's a reaction, it's going to be opposite but equal. Wow, I looked so young back then. All right, so if you notice, soccer is one of those games that has an incredible history as well as a lot of science. Now, the one thing we got to take out of this is this. As we saw in the video, an object in motion will stay in motion unless you act on it. The friction is acting on the soccer ball after you kick it. Even when you kick it, the only reason it's able to move is because you kick it. And that's law 1. Law 2, force equals mass times acceleration. Well, if you remember from the earlier video, we kick a soccer ball, we don't kick a bowling ball. Because this is what happens. Yeah, and trust me, we don't want that. All right? Because the bigger something is and the heavier something is, the harder it is to kick and the more force you need in order to move it. And law 3, for every action, there's an opposite but equal reaction. Now, if you remember from the video that I just showed, when I kicked the ball hard, it bounced off the door and bounced right back to me. That is law 3. So if you notice, with soccer, there's so many roles that science plays in it. It's not just about how much skill you have. It's about, well, how much you understand the force and the science behind the game. And that is it for day number 72, ladies and gentlemen. You did an awesome job. I was really impressed with how well most of you worked together in your reading groups today. I couldn't be more proud. If you missed any of the assignments, you can either click in the description below or go to your Google Classroom, ladies and gentlemen, and you'll find all the assignments for the week. Now, don't forget, tomorrow we have a spelling test as well as a reading comprehension quiz. So make sure you're studying those words tonight. All right? So until the next time I see you, have a great night.